All right, have your homework in front of you, and in the meantime, please just start working on this for me here. Again, if you're done, just check with your graphing calculator. Oh, does anyone need a graphing calculator by any chance? Nice haircut, by the way. Nice haircut.
Oh, thank you.
Yep.
What's the first one? Y equals minus sin x plus pi 2 plus 1. That's not a question. It's chemistry. Is it y equals 2 sine 0 plus pi 4 plus 1? Oh, really? Nice. Why would that be behind it? Because I'm a legend. And then it goes minus 3 sine 0 minus pi 2 minus 1. I just like expected to use college. Tell me, Mr. Bradley was talking about you talking too much, right? Yeah, he's like, no, we got rid of that. Talking too much. I'm just like checking for this on the page. Yep. It sounds like this. Or you know this. So you could label -4, -6. That's totally fine. Okay, that's good. One of these problems, yeah, I could shift from 0 in the center to -2. For this one, yes. You still probably, I mean, you could make it -2 pi to 2 pi for every single one of them. I see what you did, but you guess what? If you make this -2 pi 0 and this 2 pi, you're going to get the exact same shape. Okay, so to still make it from -2 pi to 0. Okay. Yeah, I did. Yeah. I did. That's right. Every one of these hit at negative pi, which is the middle. At negative pi over 2, it should be here. It should be 0. So I should see like every single one of these only have 2 full waves. This one only has 1 full wave. So that one.
Okay, so today we are just going to do a lot more practices with, well, actually, no, we have done practices with the vertical change, horizontal shifts, as well as the amplitude. We're going to add in the last bit of the last missing piece of the puzzle to the entire trigonometric function graphing, which is called the period and frequency. Now, with all those 4 things attached, it's going to be confusing, all right? And I am planning to give you guys an assessment on this one next week. Exact date, sensitive at this point, but it should happen next week because after I tell you the frequency and period, we do some practices with those. I give you a study guide and you guys should all be good. Yeah. Again, it's AP exam. You guys AP, KP, what, Chem or AP Psych? Tuesday? Okay. I'll keep that in mind. Thank you. Yep. What is it? Chemistry? AP Bio. Yeah. So I forgot, totally forgot. May was the month of testing. You guys don't have NJSLA now, do you? I hope not. Okay. PD. Okay, so 2-day window. All right, that's good enough for me. All right. Anyways, well, we'll see what happens, but I'll try to definitely avoid those 2 days because you guys have an AP exam coming up, and probably you'll just study for AP exams. That's much more important. For this, if you guys get this, you guys know that I like to give you guys a study guide, and I'm not gonna make it too complicated for this particular upcoming quiz here. And if you guys are comfortable with doing this, at least adding a period, it might confuse you up a little bit, but you know we still have some time to get used to. 2 sine x minus pi minus 1. The first thing I always ask you to do is that, what do I got to do?
Figure out the, like, not the difference, like the point, like pi negative 1.
Oh, okay, so let's start off with this, negative 1. What does that mean? That's the midline. Guys, draw the midline, please, for every single one of these. That's the first thing we got to do. Then what's next thing we got to do? Amplitude, go up 2, go down 2. We can see all that's 2 right in front of our face. So do you go up 2 and you go down 2, and it gives me a little small window in which what I'm working with here. Okay, so you want to be organized because I want to see where your max, middle, and minimum lines are. Next is what's next?
Then at pi you have to go to the midline because it's sine.
At pi you go to the midline. So this means you move right by pi. Therefore, you're starting at the positive pi. Hence, step number 3, if you will, after you establish your framework, is the starting point. So you start at middle for sine. Then what's really important is that for sine, you start at mid, and the next point in the list goes to max. And that's all you got to know. It just keeps on bouncing back and forth. So at 3 pi over 2, that's max. 2 pi, it's going to be at middle. So keep on bouncing back and forth for every single one of these, what we call quintessential points, pi over 2's intervals. There we go. I mean, it kind of looks like, if you just take a look at it from the y-axis perspective, it kind of looks like a negative sine wave, or like negative 2 sine of x minus 1. And yeah, they actually do turn out to be the same thing. Because, transitioning from left to right in terms of horizontally shifting, that actually gets you something that's, you can represent it. You can represent the same wave in many different formats here. That's what I really want to the point that I want to get to you across. Okay. All right. So after that's done, anyone need a calculator? Tony, you got one, right? Okay, perfect. So let's have our calculators out now. We're going to explore some periods here. Oh, I'm sorry. I just completely forgot. Homework questions. Let's go over some of those. I already have the answers from the previous classes, so I can cut. I went over the first one, and I went over the fifth one here, and then we're gonna go over two more questions. So the first, if you see something that's very similar to that, you're in good shape. So we have 2 sine of a theta, or x, plus pi over 4 plus 1. So what we do is we start at the middle at negative pi over 4 because we move it to the left pi over 4. And then you just keep on bouncing back and forth every pi over 2 intervals. Okay, so it's a little bit off. It's not really symmetrical about the y-axis because it's transitioned pi over 4. But hopefully that's what you see, okay? And I want to go over the second one, and then I'm going to show you guys the last one down here, okay? So negative 3x minus pi over 2 minus 1. Again, I'm going to do pi over 2, pi, 3 pi over 2. Whoa. Let's write 3 pi over 2, and then 2 pi. Then negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. I really don't have anything else to tell you other than just get used to that, okay? If I give you a grid, that's wonderful. If I don't, if I ask you to come up with your own, you got to label everything for me to see. For this one, Julia, where do we start? Pi over 2, negative 1. So that is moving to the right, and then we start at the middle line, which is a negative 1, right? Yeah. So first, let me just draw all the dashed lines here. Negative 1, amplitude is 3, so you go all the way up to 3. Some of you guys labeled this number, which is perfectly fine by me. As long as I can see that, that's great. You go down 3, which means you go down all the way down to negative 4 down here. No, I'm sorry, that's not 3, that's 2. Sorry about that. All right, so then that's the minimum line. That's the maximum line. And Julia, you said at pi over 2, you start at negative 1, which is right there, right? And at pi, where do we go? You go down to negative 4. There you go. And then you keep on bouncing back and forth. Okay. And then you should get a really nice W wave. The W shape should do the trick here. All right, and the number 5, negative 3 cosine of theta plus pi over 2. You move it to the left pi over 2, and then you have to start at the minimum because it's a negative cosine wave. And then after that, you keep on bouncing back and forth within the given framework in which I hope all of you guys are comfortable setting up. All right, let's do one more here. Negative cosine of theta plus 2 pi minus 5. So I think I can just do this. 1, 2, 3, 4, 5, 6. I really don't need to have a positive y values up there. Pi over 2, pi, 3 pi over 2, and then 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi here. All right, the starting point, or the middle line here, negative 5, top, negative 4, bottom, negative 6. The amplitude is only boring number 1. So it's going to be a very small wave compared to the other ones. Nora, where do we start here? Yes, and at negative 2 pi, do we go to the max, middle, or minimum? Minimum. We are at negative cosine once again. So we just bounce back and forth again. We get an M shape for that one. Okay. Negative 2 pi, we're at the minimum, and only from minimum, the only way to go up from there, to go from there is to go up. That once you hit your maximum, the only way to go is to go down. And then that's it. Any questions about the homework? Okay. So today, we are going to finish up the period, which is right here. Actually, the word that you should associate with this is not period. I would like for you to call it the frequency instead of calling it the period. In some textbooks, I guess they like to use that word, but they really have a lot to do in common with each other. So first of all, we took care of the red, green, and yellow that you see up there, which are amplitude, phase shift, and vertical shift. We all know how to do that now. The only new thing is frequency. And right now in your notes, it's a good idea for you to write this down. And then just kind of give a little arrow signs and say what all those things are meant, what those things mean. And forget about the steps for now, okay? I'm gonna go over that with you guys a little bit more in detail. Just the equation up here is fine. To give you an idea of how difficult the type of question that's going to be getting, now you're going to see everything. Okay, I'm not going to ask you to do this right now. Not only would you have amplitude, phase shift, and a vertical shift, now you also have what we call a frequency to deal with as well. This is where we want to get to. Okay, and first, before we can do these, we got to go over the basics. Okay, so let's take a look at this right here. Okay, so I have two tables. The first function is sine of x and sine of 2x here. Let's take our graphing calculators, okay, before you copy this down. Let's take our graphing calculators, and then we're going to graph these two simultaneously on the same spot. Some of you that are oh, by the way, could you guys all please change your Windows setting that has started with x min as 0 instead of saying negative 2 pi? Because I just want to see the positive 1 full wave cycle and just kind of recognize what's happening. So 0, 6, and then 2 pi, negative 1 to positive 1, because the amplitude is always going to be 1 for these examples. And then for y is equal to, please type in sine of x, the original parent function, y2 sine of 2x, like this. And then remember, your window is like this. X min is at 0. And then when you press graph, this is what you should see. Okay. Actually, if you guys could do me a small favor, and let's just go back to our windows, because I really don't like this x scale. X scale is basically what we're going to make each increment to be. I think we made each increment every single time to be pi over 2 in all of our graphing questions. So let's just leave it as pi over 2 for x scale. And that actually makes the max, middle, and min points or midpoints actually fall exactly in the interval of pi over 2. So actually it looks a lot better. Yep, it actually looks a lot better. Okay, so now let's just kind of visually, while looking at this graph, let's just think about what's happened here. So I have a blue wave. Blue wave is the regular parent function. Now the red wave is the sine of 2x. Can someone just verbally, yes, Sam?
Horizontal compression.
Horizontal compression. Horizontal compression, okay? Another verbal input that I got was the graph, the wave happened twice as fast. That 2 in front of the x right there, graph transformation-wise, imagine a spring. Like if you expand the spring like horizontally this way, each of those waves will get elongated, right? If you compress it, from the blue wave, if you compress it, you should be able to get like a little red wave right there on like, horizontal spring. The way that I want you to kind of remember it is, I like to think of it as if it's 2 in front of it, my wave happens twice as fast. So a full cycle always happens when I have something called a one going up the stream and one going down the stream. That's one cycle. When I double the frequency, if I have my B value as something else other than 1 instead of 2, now I not only do I have one full wave here, but I also have another wave here. So I multiplied it by 2. My wave is now, there's double of the amount of the frequency there. Okay? So the frequency is a measurement of how many waves it's going to happen within a given interval here. if I go back to this slide, my original function of sine of x is 0, 1, 0, negative 1, 0, as we have all discussed. If I plot the points, and I'm going to make this one as 1 and negative 1, 1, 0, negative 1, 0, this is the way that we saw just now. But if it's sine of 2x, guys, like we said, it's a horizontal compression. 0, pi over 4, pi over 2, 3 pi over 4, and pi. If you take a look at all the x values compared to what you have originally, your x values actually gets halved to complete a full cycle. So what I mean by that is, if I were to do sine of 2 times 0, sine of 2 times pi over 4, because that's the next one on the list, sine of 2 times pi over 2, and you get the idea. You basically get the original 5 values here. So that is going to be sine of 0. This is going to be sine of pi over 2, sine of pi, sine of 3 pi over 2, and sine of 2 pi. So these values 0, 1, 0, negative 1, 0, they happen exactly the same for actually these values. So if I were to plot the new wave, I would do this. At 0, it starts at 0. But at pi over 4, which is only halfway between 0 and pi over 2, that's where the maximum is going to occur. Then at pi over 2, it's going to go down to 0. You can already see that it's going to be double the rate of how fast the wave is happening. Then at 3 pi over 4, which is halfway between pi over 2 and pi, I reach the minimum. And then I go back up to middle. And then if I repeat the process for this, up, middle, down, middle, that's what the graphing calculator showed. So if you want to memorize it in whichever regards that you're more comfortable with, horizontal stretch curve versus compression, in which what we're familiar with graph transformation, or the wave is happening twice as faster in terms of rate-wise, that's also another great way to kind of think about it. So whatever works for you guys. All right, so I'm gonna give you guys like an application problem to do with this one. So let's take a look at a problem that we can do, which is right here. If you need me to go back to the previous slide, please let me know. But let's say I present you with a question like this, because these are the type of homework questions you'll see for today. Y equals 2 times sine of 2x. Okay, so very similar to the one that we have just done. And let's say I ask you to plot it. Okay. And some of you guys might get going at it already, but I just want you to take it a little bit slow. Just write down the function and just try to draw the grid nice and easy. Like, just draw a little bit big for me, okay? Don't draw it too small. Amplitude, frequency, the frequency, guys, and the new period and the each increment. Like, these three things are new. I'm going to ask you for these things here, all right? So we should all know what an amplitude is. We know it's 2. It's whatever's in front of sine. Okay, cool. The frequency value, okay, I want you to always remember it as the b value. In other words, the frequency is the number in front of the x. So the frequency is also actually 2. This is your b value in that equation that you have just written down. Now, this number 3 and 4 it's where it actually gets really tricky. Okay, I say a new period. Okay. Frequency is how fast something is occurring. A period is how long it takes for one wave to happen. Okay. So one wave that we all know and love, those 5 points that complete this kind of like a wave, how long does it take for a sine of 2x to complete its journey? That's the question. Originally, for every sine wave, it takes 2 pi. From unit circle, we already know that one full circle happens at 2 pi. Yes, Sam?
So if it's 2 sine or sine 2 would be just pi.
It would just be pi. It happens, so it can complete one cycle because 0, 1, 0, negative 1, 0, those 5 points, it completes one cycle in pi. So if I ask you to find out what the new period is you're going to write down pi. Yes.
Go back to the last slide.
Absolutely. Even this one, right?
Yeah. So are the values the same for sine of x and sine of 2x in both tables?
The values in which the max, middle, and min, they're all going to be the same no matter what, right? But notice the x values, they changed up a little bit.
Oh, I didn't notice that the x values.
They have to be different to accommodate the two. So like if I double each of the x values, I get my original function, which is, pi over 2 and things like that. Julia?
So to find the wave period, it's the 2 pi divided by the frequency?
That's correct. Yes. That's the formula. Oh, actually, sorry. Sam, you still need this up, right?
No.
No? Okay, great. So here, new period, like Julia said, I'm going to show you the formula eventually as well. It's the original period for sine and cosine because of the unit circle is 360. You just got to take that and divide by whatever the b value says. If it's 2, you got to half it. So then, because it happens half as fast, like it takes half as much time for it to complete a one full cycle of journey. So the new period is going to be pi for this one. And then the last one here, it says each increment. Okay, so this is for your benefit. This is for you to understand how to graph this easily. If I tell you the new period is pi, it means that I want you to make the last number on the x-axis as pi, because we always made it from 2 pi to negative 2 pi because our full cycle was 2 pi. You don't have to do that anymore because your period has now changed to pi. So then how do I get all of those what we call essential points like max, middle, min, and things like that? If you go back to the 5 points that we always use was 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if you notice that each of these are proportioned, where is it? Each of these are portioned exactly equal in equal amounts. You just have to take whatever that value is at the end, which is 2 pi, a full cycle, and you have to divide it into 4. And that's what each of these increments you're going to make. So for each increment for this new period, you take whatever your new period is going to be, and you always must divide that by 4. So here, my new period is pi. So my each increment, I'm going to make it into pi over 4. So I make the first increment as pi over 4 instead of making pi over 2. Then I'm going to make it as 2 pi over 4. You can leave it as pi over 2 instead if you would like to. Then it's 3 pi over 4. And then this technically is 4 pi over 4. You keep on moving increments of pi over 4. And that's how long it takes for you to alternate between among those points, max, middle, and minimum. Then I'm going to do the opposite. Negative pi over 4, negative pi over 2. No, negative 2 pi. What am I doing here? I'm going to keep it consistent. Negative 2 pi over 4, negative 3 pi over 4, and then negative 4 pi over 4 here. Okay, so we're actually going from negative pi to positive pi. That's the only thing we're doing. Yes, Sam?
Instead of changing the values, could you just compress the graph and leave the values the same? So you get so it would essentially still work.
So what you're saying is you want to use the same graph of 2 pi here, but your wave will be compressed like this.
Exactly.
That's okay. The only problem with that is then you have to draw so many waves in between.
Right.
That's a lot of work to do. So that's why I'm always asking you to kind of change the x values, because that's a lot easier for both you and me. Me to grade yours and for you to draw yours. After you establish this, This is kind of like your step 0, if you will. Like this is the first thing you got to do even before you set up your framework, because if your x-axis is not correct, you know, it's all subject to change based on what the period value is going to be, or your frequency value. After you set up your x grid, back to square one. You know, you do the framework of 0 up to down to. So you go to max and you go to min, and you keep on alternating the points. So here I have 0, maximum at pi over 4, because that's how long it takes for you to change from middle to maximum and vice versa. So middle, minimum, and then middle, and then you just keep on alternating the points, right? So I'm gonna get a wave that looks like this. For those of you that kind of understood and copied this down, I need you guys to type this in your calculator and then see what happens. Actually. And the one thing I'm really going to ask you to do is you got to change your x and y scale now. Your x min should be now at negative pi, no more negative 2 pi's. Your x max should be at pi. You want to keep it consistent to whatever you've sketched. Your y min should be at y equals negative 2. And your y max should be at positive 2. And if you get the exact same thing as you see up here, as what you see up here, then you are in good shape. Oh, and by the way, make each x scale to be pi over 4s now, because that's what you made each increment to be. This is kind of like x scale in a way. That should be the window. Press graph. There you go. I really just want to see 2 cycles like this. One wave and another wave. I don't need to see like 5, 6, 7 different waves from, you know, whatever the scale that you guys decided to do. 2 full cycles is good enough for me. That demonstrates that you understand what type of wave this is going to be. Okay. All right, so now that we understand this portion, I want to give you guys something different. How about this one? Okay. Not only do I put a little twist with the sine versus cosine here, but I also put 1/2 this way in this case. Try this on your own. Let's explore this out. If you guys want to sketch this first on the graphing calculator and get the answer from that way, that you can. Just feel a little bit more comfortable. You got to be able to tell me all these components, please. Yeah.
For the new period, you put 2 pi over what b is.
Yeah.
increment is always your x scale. Oh, I'm sorry. Yes, that's fine. But then x min, why don't you make it? Well, x min and x max, they correspond to the new period now. So it would be x min would be the negative new period, x max would be the positive. Because your window is not set up correctly. So here, what you want to do is, first of all, this is, you just get a small favor and just write down the, okay, so negative, so 3 and negative 3, you start at maximum, right? At pi, you gotta go down to the next crucial point, which is middle, which is here. And at 2 pi, and at 3 pi, you go back up the middle. You want to draw all the way up until 4 pi. So it's gonna look like this. Yes, pi, correct. Max, middle, min. Exactly. Perfect. Hold on. Well done. Great. Perfect. Great job. Good. Excellent. Well done. A little curvy, okay? Yeah.
Wow. You guys are catching on to these quick. So I think what I'm going to do is I'm just going to go over this, present you guys with one question that I actually showed you in the beginning of the class, because I feel like some of you guys can actually do this. I wasn't planning on doing it at the end of today, but we'll just end on that slide. Amplitude, frequency, new period in each increment. Okay. So 1/2 x, Sam might say this is horizontally, what would you say? Well, we used to compress last time, right?
So this one would be horizontally stretched.
Exactly. So it's going to have opposite effect because now it's 1/2. Every x value is now going to be expanded because it always has the opposite effect. So amplitude, we all know it's 3. Frequency, new period in each increment. Abby, could you help me out with this one?
Frequency is 1/2. The new period is 4 pi, and then pi.
And each increment is pi. Exactly. So rather than having a 2 pi, now this is expanded. Okay. If I were to draw this originally from, 0 to 2 pi, which was our original parent function, where we get a full sine wave, now you only get half of a wave because you need another 2 pi to get a 1 full cycle. It has been horizontally being expanded, okay, stretched. So that is what's happening in terms of, in graph transformations. But if we want to just, change our x scale so it's going to be easier for us to draw, we're going to make that last one, 1, 2, 3, 4. We're going to make that 4 pi, which makes each increment to be pi, 2 pi, 3 pi, and then 4 pi. Reverse engineer it, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Going the opposite direction. Now, again, same thing. We establish a framework at 0, at positive 3, and at negative 3. No horizontal transformation. That's good news for me. So then I have to start at cosine, which starts at, Abby, where do we start at? Max at 0. There you go. No transformation for horizontal. So we start at 0, but we go to max. Then every other point, just repeat over and over again. And then you're going to get, again, a W shape. Okay. Let's say that you want to sketch this to verify your answer. Again, you need to change your X windows. Your minimum for X is negative 4 pi. Your max is 4 pi now. With the scale, X scale should be pi. Your every increment is pi now. So if I go back to my calculator, okay, so this is 3 cosine. What is this? All right, so I guess I have to use this one. 3 cosine of 0.5x, same thing as saying half x. Windows, negative 4 pi. Positive 4 pi, x scale will be pi. X, y min negative 3, y max 3. There you go. Matches exactly to what we had. That's how we know that we did this correctly. And this is 2 full cycles. That's what I want to see from your graph papers as well. All right, so we got about 15 minutes left. Let's spend some good amount of time and just really think about it. I just want to just challenge you guys to do questions like this. Okay. Now we're kind of incorporating everything together, and I'm really just escalating up a lot right now. But quite frankly, you have every tools at your disposal to be able to do a question like this. Please answer me every single one of these questions, and then be neat as possible to sketch this out. Once you're done, graph calculator, please. Check your answer with your graphing calculator. Then we're going to end with this equation here today. Sorry to interrupt you guys. When did you guys say the AP Psych exam was again? Monday? Tuesday? Okay.
Should we like for fascia, should we say like right or left or that?
Mm-hmm. You do a little arrow sign. Because you told me the frequency was 2. So it's 2. 35. Great. Yes. You gotta still do this and open up another parenthesis. So yeah. We could have multiple parentheses. Like when you're typing this in, you could do this like that.
How do you make the? Oh, you're. Okay.
You can add on that, yeah. By default, they do cosine parentheses. Just the two another parentheses like that.
Mr. Kim,
Yes.
when we're graphing it on our graphing calculator, what should we set like the max and min to?
So your X max should be whatever your new period is, but the positive new period. And X min should be your negative new period.
Okay, thank you.
Yep.
It wasn't that fun, but.
I mean, it's not like funny.
I know, it's not
There's
that
nothing funny about that.
Okay, seems like most of you guys got it, yeah? With the graphing calculator, when you verify your answers, I hope that you guys are going to get the same thing. Joshua, Ryan, can you actually help me out with the 1 through 6 up here?
Okay, so the amplitude is 3, frequency is 2,
Uh-huh.
new period is pi, each
Increment.
increment
Yep.
Is pi over 4.
Great.
Phase shift is, the phase shift is pi over 4 to the right, and the vertical shift is down.
1 unit down. Lot of stuff to take into consideration. So again, the very first step that we got to do is we got to figure out just what the heck each increment is going to be, which is this. So then that's what you do first. Pi over 4, I'm going to actually do a different color. Pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and then negative 4 pi over 4. Okay, so that is going to be my X max and X min window setting. Then my Y values, it could be, from positive 4 to negative 4. I think it will contain the graph here. My middle, after you do that, that's step number 0. Then you got to do your vertical shift and then your amplitude together. We basically have taken care of all of these by doing the new x-axis. Amplitude and vertical shift. So I go down 1, so it means my middle line will be at negative 1. My max would be positive 3 from that, which is at positive 2. So down 3 here will be at negative 4. So this will be at positive 2, negative 1, negative 4. Hope you guys have the same thing. And those values tell you your Y max and Y min. Okay, you really need to display the setting in which where we're going to be working at this. Then the last step that you take care of is the phase shift, along with the fact that we're dealing with the cosine wave. So the phase shift here is pi over 4 units to the right, like Joshua Ryan said. Joshua, for this one, do we start at max, middle, or min at that starting point? Very good. So it's cosine, we start at max. So at pi over 4, I know I'm going to have a maximum. Then for every pi over 4 units to the right or left, I am constantly alternating. So that is a wave in which what I'm expecting to get. It should look like that. Yes, Sam?
Is the phase shift the X minus pi over 4?
Whatever's inside the parentheses right there.
Okay.
Yep.
And then also for the new period, like how would you go about, like how do you determine that?
New period is always, you remember the original period for cosine is 2 pi, or for sine. Got to divide that by the b value, which whatever you set for the frequency. So you take 2 pi divided by 2.
Oh, okay.
Okay. Yes, Steph?
For the each increment thing, will that always be your first point, right? Like right after 0?
Yes.
That'll always.
Well, it said phase shift units to the pi over 4. That's why I started at pi over 4.
Okay.
But each increment, all that matters is that you make these to be as increment of pi over 4s each time. Yes, Joshua? You're allowed to use your calculator. Yes, of course. Yep. What do you mean by logic this out, by the way? Oh, no, I want you to use it to check always. Yeah. Because I think some of us at home will have the disposal of using the calculators at home. So might as well give you guys also the chance to do so. Okay, so let's verify our answers, and that's the final thing that we're gonna do. So to type this up, it's gonna be just a bit of a pain, but let's go through with this one. So we have 3 cosine. Can someone just kind of remind me what was it again? 2 times x minus, was it pi over 4?
Yep.
Pi over 4. The double parentheses here and then triple parentheses there to complete that, minus 1. Why can't I type anything? What is this? Okay, there we go. Minus 1. And then Windows, x min would be at, I think it was negative pi, because we divided by 2. And this is at pi. Sorry, my calculator is being really weird. I don't know why this is stuck. Okay. All right, so now I can move pi. The x scale here, I'm going to make it pi over 4 because that's what my each increment was. Y min was negative 4 and y max was at 2. So let's check. Ooh, was our Windows setting incorrect? That is correct, right? So then the window, if I just do this at negative 1, that's my halfway line. That's what I should get. Okay, so that is the homework. Yes, this type of question. Well, not to this extent. All right, thanks guys very much. Have a great day.